is a Rastaman that provides celebration. Cross every nation, across the ocean. Check this here one.
Hey, hold on. So I am, looking for some... Yeah, usually I turn on music when I'm, like, you know, just trying to get something done, and I don't feel like talking, or something's not really that interesting, it's just, like, busy work that I gotta figure stuff out. Yeah, but, so I am trying to figure out, going through some really old code and trying to figure out if I ever used, a thing called TextSubImage something update or whatever. What the heck is it called? I'm searching through my old repos. I'm searching through my whole repo drive right now. But I have like really old code that's like in many places. Now I could just, you know, do this thing called RTFM and just, you know, read the documentation and do it that way. But it's like, I know I've already written this code somewhere, so I'd rather see it in use somewhere to be like, okay, this is exactly how it needs to be done, rather than reading the documentation, getting it wrong, because I can't, because I just, you know, fill out the parameters wrong for some reason, and then it just doesn't work. So I'm trying to figure out where I've used this command before, so I'm checking the R drive right now. R drive for repo drive. I literally have a thumb drive dedicated to repos, and hopefully it's kind of like in here somewhere. So that is what I'm doing. So hopefully when this search, I'm searching the entire drive, even though it is kind of like this is this search right here is inside of oh, do you mean File Explorer or web browser? So, okay, we've almost searched through everything. I'm using this web browser is, okay, the File Explorer, that little thing you saw coming up, that was a Notepad++'s search utility. So yeah, here we go. I thought it was somewhere, so where the heck are we? Like, what? I gotta full screen this and figure out where this stuff is coming from. Auto hotkey. Why is this an auto hotkey? Auto hotkey 04. What? So I didn't even know I had a thing called AutoHotkey 04. I thought I only went up to 3. That's really weird. Hackback text for TextSubImage 2D. What the heck is this? Hold on. Let me just open some of these. This seems to be a shortcut file. Oh, this is a backup. This is a backup file. Oh, yes, this is a backup file. Okay, close that. Okay, yes. So I know what that is. Okay, that's a backup file. And... doc. Well, here's some notes. That might be helpful. A2JC. Uh-huh. Okay, let me... Okay, let me look at what I got here. There we are. There's the code. TextSubImage 2D. That's... okay. Right there. That's what I was looking for. Cool. So, I found it. Anyways, let me go open up my chat here. Oh, file. Oh, I use search everything, but, want to move to, bear grep. It's, fat. Oh, yeah, like, yeah, like, grep. I mean, grepping for something like that probably wouldn't be too hard, right? Like, if we could try that right now, right? So we could try, let's go Windows E key for a second. and then let's say we did the R drive, right? So repo drive, and then we could do git bash here, and we could do, I think I might have a shortcut for this, grep case insensitive. Okay, so grep, and then, actually I don't want to search in a specific file, though. I don't know, I have to make some shortcuts for it, yeah, but I don't know my grep as well as I should. But at one point I was using grep quite a lot, not anymore. So, anyways, I found the thing I'm looking for, so forget about grep for now. But yeah, you're saying grep is faster, so I should probably... Here, let's go look that up. Why don't we go look that up, and, grep search recursively. Also, I'm going to check my notes, though, because that could also be somewhere in my notes already. So, let's try recursive grep. Hey, look, I have a shortcut. It's called egrep recursive. Let's try egrep. Egrep recursive. Egrep... I forgot what egrep is. Is egrep like the easy grep, where you don't have to, like, do regular expressions? Here, let's just try that. So, we're looking for... So we already found the file. So let's take a look at that for a second. TextSubImage 2D. Not grep, it's a Win pro. Oh, it's a Win program. Okay, got ya. Yeah, I used to use a search utility. I used to have a good search utility because I used to, like, search things quite often on my computer. But I haven't actually needed to... it's been quite a while since I had to actually delve into... Yeah, I've used something like this before, yeah. Like a search utility kind of thing here. I'm gonna take this for a second. I'll put that into my notes, because that could be useful for next time I have to do this nonsense. So... bear grep, super grep, and super grep. And you can also say, like, grep UI, grep UI, grep UI, Windows grep, and Windows grep. Okay, yeah, so we have that in our notes for next time, if we have to go through this. John Blow uses it, so it must be very good. I mean, yeah, I mean, you know, he obviously does something right? So, if, like, I will appeal to, you know, I think an appeal to authority is a perfectly good argument, as long as that authority figure, knows what they're talking about, you know? And Jonathan Blow is someone who knows what they're talking about, so, I'll take that, yeah. So, he shits every soft in the existence. Soft like poop or soft like... Okay. So we found this. So let's steal this, right? So let's gonna... So this is gonna have to be rewritten. So it is written in a way that is for... This is WebGL, so it's pretty much the same signature, and we can cross-check it with the documentation to make absolutely sure. But let's make a little snippet of this. So, so let's say... And it's stolen from full file path to clipboard. just turn this into a little snippet. And we'll just call it, alright. Let's just put this into a nice little section really quick. And then we'll save this off into a snippet. So let's go into AutoHotkey folder. And shortcuts, SE files. This is technically JavaScript, so JS. And snips. We got snips WebGL, so, oh look, TextSubImage, we already have it. Okay, let's see, so TSI2D. Let's see if this is how much different this is from what I kind of put in here. Is this kind of the same thing, or is this better? Is this worse? I would say that this snippet is arguably worse. It looks like, first of all, I'm not sure if it's in production code, but this looks like the formatting here is kind of Yes, game stuff. Yes. OpenGL stuff I'm looking at here. Yeah, this looks like crap. This formatting's better. Dirty sub-selection rectangle, so kind of telling me what it is. That's nice. The width. Yeah, this formatting here looks much nicer, much cleaner than this. So I'm gonna say TS2D ver2. I'm gonna say version 2 because this version of the snippet is poo-poo. So let's rename this to TS2D version 2 and say, you know what, this snippet is actually much better. And then over here, I'm gonna just take the new snippet and put that here. So SC files, whatever. Paste file. Then also I need to make TextImage2D. Oh boy, that's did not expect that to paste anything. Okay, here I'm gonna say something like update portion of image, update portion of image, update subsection of image, update subsection, partial texture updates. So, CT TextSubImage 2D snip, right? So this is the snippet command. Let's put this over here. And then TSI2D TextSubImage 2D. And portion of image subimage image sub, I don't know. Partial image, partial update. So the thing is, the next time I search for this, I just want to be able to find it, hopefully a little bit easier. So I'll take this, paste it in here, and then I'll check your chat. Let's just index this. It's the same exact shortcut, but let's give it a little number, right? So this is the same exact text, but I want to make this text and this text unique when I'm looking at it. Alright, let's close that. Okay, let's put that over there. And so this snippet looks like what I want. And I'm going to put the chat back on the... I'm going to put the chat... yes, exactly, yes. Exactly. I'm going to put this chat back up on my top monitor. And... so the way this is written, it's WebGL, but the signature, or not the signature, but the prototype, the prototype for the GLSL, sorry, not GLSL, the prototype for OpenGL and the prototype for WebGL, I believe, are exact matches, or at least last time I checked. So let's just cross-check the snippet we stole from production code. So it's actually, I stole it from some WebGL code that actually works. And the reason I wanted to steal this from working code is because I feel like I'm much less likely to screw this up if I steal it from working code and then just change it around to my needs here. So let's look at the things here. So target, this is target. I commented it as target, nice. Okay, level, aka level of detail, nice documentation here. Then we got X offset and Y offset. So I can see why I named things as I did here. X offset, Y offset, width and height, which might be kind of confusing, because basically that is just a, that is specifying the rectangle, right? So that's why I have them grouped here, like so. And we see origin left, origin top, dirty sub selection rectangle. So we're going to specify it by the first pixel in the top left, and then we're going to give it the width and the height. Okay, I understand. Now, the next part is important, is the source format and the source type. Well, I always use integer textures, so that's another reason why I wanted to steal code from somewhere else I've already written, because, you know, if you get this part wrong, you'll be in kind of like a world of hurt. Now, we can see format and type, so I kind of changed this to source format and source type, because it's not immediately evident here that it's the source format and source type, like, you know, maybe that's the destination. Well, I guess the source and destination should both match, but... and then const void pointer data. So it looks like there is one extra thing in here that's not in the other thing, right? Because it looks like we have this void pointer for data, but then we have this thing here, source offset. Oh, okay, I'm familiar with the source offset. It's, the source offset here should just be 0 if we're going to use it. So if we look in here for a second, let's go actually see how we use this. I feel like some of these parameters should have been better inlined. But, so it looks like we should also maybe be careful to, so I'm going to guess this value is probably like a 0. Oh no, component offset. Okay. And did we say what this was stolen from yet? We said what this was stolen from so we can find it again later. Okay. The link I found says it's pixels instead of data. Okay. Target, level, offset, height, type, data. Specifies a pointer into the image data in memory. Yeah, and the pointer will be... So the way OpenGL works is the pixels are encoded in a byte array, so like RGB and A bytes all separate. Yeah, documentation is... it's not... The documentation isn't too bad. But it is a lot of stuff to look at sometimes, where it's like... blah. Sometimes you have to know what to pay attention to and what to just skim over. Now, hold on, let me look for the word offset for a second. Offset. Where's this offset coming from? Okay, X offset, Y offset. Okay, you know what, we're just gonna... we need a visual confirmation that this is working properly if I use this, because I'm worried that I'm going to try to use this command and it's just, I'm not going to use it correctly. Let me think if I have any code that actually uses the proper OpenGL function here, and I don't think I do. Huh. Yeah, I think we're just gonna have to go with this. So, let's just figure it out, and I guess what we could do is we could kind of steal this, right? We can steal this to work with it first, but this isn't the right number of parameters, so we'll figure it out when we get to it, right? So we know that this needs to go in here. We don't know exactly what it needs to be, because it's not exactly this, but we'll figure it out as we get to it. And this text subimage 2D, we need to look in our bindings. So we have like a bindings file for this kind of stuff. Let's close this one. Let's try to close some things and not have them distract us. So we have a bindings file. And we might not even have this binding exposed. Yeah, I don't think we have this binding exposed. And this is going to get really... This is one of my older libraries, so like you can see like some of the stuff is like all like wonky and like different column limits and things have been edited and not put back together. So there's some things that are just like blah, like not as pristine as the other code I have, right? Because it's like... but it looks to me that this library does not contain the binding for, yeah, like, all this is nonsense. Okay, well, this looks like where I was adding, so it looks like this is new stuff. So if we look at GL uniform 3F, GL uniform 1F, like we can see that we have some nicer formatting here. So it'd be good to kind of look at this and kind of look around at GL uniform 1F and see how we did this. Yeah, so it looks like I started kind of like throwing things in here into the bindings, and it's like everything's ugly, but we might as well just kind of start work with what we have and just try to make sure that the new stuff we add kind of like uses our new formatting conventions and all that stuff. So so this says, okay, I see what's going on here. So even the namespaces, right? So these namespaces are just PFN, 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 PFN. So they're not like, they're not namespaced out to the crazy extent that I've been doing with newer code. But yeah, so let's just keep on, like it's gonna get verbose, but let's just say, let's just keep on going with this kind of thing, this pattern here with the newer code. And just say, okay, well, it's 2021 02 10, right? So let's just take that and just roll with it. And it's like, does the date that I added new code really matter or not? Well, it kind of matters in the sense that as I'm looking through code and trying to add to something that's very old, and I'm trying to figure out, well, what's the correct way to go about this? And I have, like, old and new code mixed in. And it's a complete disaster, then these date stamps actually start to be somewhat useful, because I want to know what code is the newest, what code's the oldest, right? So 1206, 1106, 1104, 1106. So it looks like some of these things are organized by date, but then some things got shuffled around because I wanted to keep the 1F, 3F, and 4F kind of together, it looks like. And do we have... Are my dates... It looks like I put the newer date on top. So, looks like I'm putting the newer dates on top. That's looks like what I'm trying to do here. Because I see 11s, and then I see 12. So let's put this here. And let's, okay, and I see that. Okay, so I see that I'm writing it as I would access it, and then I'm writing the bindings over here. So the, declaring the function pointer type, and then the function pointer type has the name of how you would use it if you included the OpenGL headers. So, let's move this code over here so that we can look at it. And, oh, but when I do that, god damn it. Okay. So we know that it's going to be glTexSubImage 2D. So let's just insert this here. glTexSubImage 2D, and that should be a capital T, I'm pretty sure. Okay, and that's not actually declared anywhere yet. We have to kind of go through the code, and we're just going to follow the patterns that I've already written in the code, right? So we're just going to continue to be like, do this, right? Like anytime we encounter a new thing, we're just gonna follow the patterns that are already in the code, and as long as we do that, we shouldn't have to think too hard about how to get this working to get access to the function pointer we want. So, right, so it's the 10th of February, or however you pronounce it and spell it. Nobody knows. At least that was the consensus on Facebook when I was looking at memes. Okay, so it looks like we can just steal this stuff, and actually we only need to steal one of these. And then we're just going to rename it. So we're going to take this, and this is a capital T, and then this. So we're just going to yeah, sometimes I read memes, and they read like some type of like Magic the Gathering card game thing, where it's like, yeah, it's like, yeah, when you try to, sometimes people, you can tell when people are trying to force humor or make things, or be very contrived. It's like, you know, yeah. Anyways, glTexSubImage 2D is here. Okay, let's keep on kind of grabbing onto this, and just use that to kind of look for the new places that we have to, like, insert things, right? So that is really bulky. I get the reason why I wrote it that bulky, and that's fine, that's fine. If we're gonna, I need to just stick to the patterns that are already here, because that reduces the amount of thinking I have to do here. Because, like, I just want to get a function pointer to the library and load it at runtime. This is not rocket science, but I sure wrote my code in a way that makes it look like it's rocket science. If I could do it over again, I would probably figure out a cleaner way to do all this. But for now, it's a disaster, and we're going to fix it. We're going to get it working, and then we're gonna once again forget that this file ever existed, right? So it's kind of this thing where, you know, I had this boss who like wrote code that was horrible looking, and he always would say something like, you know what, I just want to write it, and then I never want to ever have to look at it ever again. And that's where I am with this code. It's like I just want to write it, get it working, and then I just never want to look at it again, right? So We could try to make some sense of this, though, right? So define type, define instance, right? The type is the function pointer to this. Okay, that makes sense. Now, the function pointer types in this library. you would fire that, boss? Well, yeah, unfortunately, that's not really the way that works, but, you know, yeah, man, he was hard to work with, though. Or not hard to work with, but I don't know. Gave me some anxiety there, like, every time the phone would ring. He worked from home, but I worked in the office, and, like, I'd be trying to get something done, and if I didn't get, like, code committed in time, like, he would call me up and be like, hey, what's going on? What are you doing? I always felt like I was interviewing for my job every single day. Oh, God, that was stressful. So let's see. So G is most likely a macro for getter, and it's like having a very small one-letter macro in the code here, where it's probably defined like way up somewhere. That's a bad idea, right? It's like I got these nice explicit macros, and then I just have this little macro here, and I guarantee this is like a getter function, and it's gonna go do like a get proc address on this. And then it's going to cast it to the correct type, and that's all good and whatnot. But holy crap, that's not like... That's, not the best way to go about that. But yeah, we just... So even though... Yeah. And yeah, let's, only that line is enough of a big red flag to... No. Yeah, like, yeah, yeah, so like, yeah, I don't know, I wanted to work there, you know, it was like a data visualization company, so I was like, oh, that's interesting, I would like to do that. Yeah, always a sweet spot, yeah. Right, so it's like, there's that joke where, like, if you have 3 programmers, you have 3 systems. If you have 4 programmers, you have 4 systems. And I kinda... That joke... There's truth to that joke. But also, I wonder if... Now, what... I wonder if people are mixing up cause and effect, though. Because, like, okay, if I work on this engine, and eventually I want a sound... I want, like, a sound... engine in here, right? Well, then I'm going to hire another programmer to do the sound, because it's a unique enough, compartmentalized enough thing to where I could get another programmer to work on that and they wouldn't step on my feet, right? And then if we wanted something that was like gameplay, right, and it was gameplay and it wasn't related to rendering, then I would also like another programmer for gameplay, because it's a unique thing where we aren't going to step on each other's feet. You know, so I do definitely think that, you know, you should try to think of organizing your code in a way where you can have different areas where someone can have dominion and not step on somebody else's feet, right? So if if I'm working on the rendering engine and someone's working on the sound, then we should be able to do our own thing and not kind of collide with each other. Okay, so text sub-image, so there we got that there. Let's keep on going and looking for more stuff. So we know that eventually we have like a wrapper code somewhere in here for this kind of stuff. So this looks like wrapper code right here. Yeah, this is wrapper code. So we got a type def, and I do like the way you write function pointers. Because now that I've seen how you do it, I'm going to say that I'm no longer going to put the asterisks as part of the type def, because it's definitely easier to read the way you do it. But the thing is it's already done this way in this file, so I want to, as much of a cluster mess with a capital F that this file is, I want to maintain some uniformity between the way like everything is being done here. So we're going to just steal this. We're going to steal this, and we're going to paste it over here for a second. And we're going to just manually edit it to be TextSubImage 2D. And I'm going to edit it in another file just because I'm paranoid that if I don't edit it in another file, there is the potential that I'm going to accidentally edit the original file rather than what I'm trying to refactor here. So let's go over kind of everything that needs to be done here. First of all, we don't know what the parameters are, right? So let's open this up and just say, you know, parameters. Params go here. So I gotta figure out what goes in here. And then we just gotta replace these, right? So we got the type, and then we have the instance. So the type is all capitals, and the instance is lowercase. That was kind of the convention for this library. So this is a wrapper. This is a wrapper function, I believe. Once again, we need to know what the parameters are. So this is params. And glTexSubImage 2D. So I didn't want to worry about, like, things like, I don't know, compiling and linking and all the intricacies that go around with that. So I was like, you know what? Screw this linker thing. I don't know how to use a linker. I'm just going to load all my function pointers at runtime. And that is how I ended up with this mess. Do I regret it? Not completely yet. I'm just like, whatever. So PFN. So we got a function pointer type defined as PFN. That's good. This needs to use whatever the parameters are. So, this needs the actual params. So whatever goes in here, this is the actual params. These params are formal params, right? So these need the... Whatever is going in here, it's formal params, so we'll fix that when we find out what those are. True, yeah, that's why type def is genius, because it forces you to use star when declaring function pointers, because you can't declare function pointers. That's why type def is genius, because it forces you to use asterisks when declaring function pointers, because you can't declare function pointers. Oh yeah, you mean like you can't declare as variables. You can't declare functions as variables. Yeah, there's no, it's not like, you mean it's not like JavaScript where you can just kind of like pass around, you can't just say, there's no like generic function type, right? There's no built-in function type in C code. It's not like in JavaScript where you can just kind of like say, hey, this variable, give it a function, and then you're done and it's easy. Okay. So let's look at that documentation again. Where are you? glint, glenum. Okay. So, let's see. I think I have a... Yeah, I guess lambda might be the... Lambdas, that's a fancy way to say function... You're talking... No, I'm not talking about the, like, single-liner inline functions. I think that's like a lambda. Like, lambdas are like, this kind of stuff. Like, where you do something like this, where you're like, here's some function... Here's some function that takes, you know, arg1, and then, like, this thing, and then, you know, blah, 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 blah. Yeah, closures, right? So closures, usually closures, people think of them as a function in another function, but it's a little bit more complicated than that, from what I remember, because closures, closures remember the state of the parent function, right? Or the parent scope. Like, when a closure, even though if a function is declared inside of another function, that function has access to the outer scope, and so you can do weird nonsense with that. But I might not have my mind properly wrapped around what a closure is, because my assumption was closure has something to do with the function being able to, you know, reach out to the outer scope and access local variables of the containing scope. Well, this is specifically JavaScript that I'm talking about. But anyways, we're not doing any JavaScript nonsense. We're writing C code because we don't have to wrap our mind around the weird ways that things are happening, you know? So I have some shortcuts, which I cannot say out loud, but glenum... Aha, so it's an unsigned int. Okay, fine. So unsigned int, we could really probably just say u32. U32, right? glenum is a u32, and it's going to be called target. Okay, and then... Because go-tos and stuff. Alright, make some tea. Tea's good. I'll just be filling this out painstakingly. Int, so that can be an int32. And offset, glint, int32 x offset. Okay, gl size ei int. Okay, cool. So that's int32. Width. And then I'm assuming we have height next. Yep, height. And then after height, we have format. Unsigned int, so u32 is the glenum, and that's format. And then after that we have type. And then we have const void pointer data. Okay. Okay. So we got all these nice little types. So we got U32 already. We got int32. So we got most of these covered. Alright, we got this covered, we got that covered. The only thing we really need to add is define const void. So const void pointer. And then we can just make a little checksum. Then here we're going to undef const void. This undef needs 2 spaces. Okay. So we got all these nice little parameters, and this is all going to be duplicated over here. So this is the function pointer type, and then this is an exact duplicate over here, which seems kind of like wasteful, where it's like, okay, well, if this is completely duplicated, why not like put this signature in its own file or something, and then, you know, we could include it here, and then we could include it here, and then we could make sure that it's exactly the same. And I will say I have done that before, but it just makes the code like really hard to follow, where it's like you try to follow the code, but it's like, yeah, I don't advise doing that. It just makes it, because then you have like stuff like all over different files and whatnot, and it just makes it a nightmare to like read the code. So even though, you know, this does seem kind of frail, because this signature here needs to exactly match this signature here, why not just put this in its own file and include it, and then include it here? I find that's a bad idea. I find that I've done that before, and it doesn't work out very well. The code just is less maintainable, and it's just hard. It's just harder to work with that way. So okay, so function pointer sated, PFN, call wrapped function pointer. Okay, that's all good stuff. So now we're just gonna steal this once again. Right, just so a lot of just cut and paste code, right? And so now obviously you can automate this process with like some macro magic, but it is my opinion that we're better off not trying to automate this. Because though it's ugly, at least we know exactly what it does. Even though it's ugly and very bulky, at least we know kind of like exactly what's going on. 1, 2, 3, 4. And that's the most important thing. Knowing exactly what's going on. Okay, cool. So now the next question is, do we want to fix this formatting? Do we want to indent by 1? Because I feel like we could start indenting by 1, so that we know that we're in like a section for... It's not too... Well, this gets out of hand then. That's not a battle I want to wage right now, and with indenting this. So we're just gonna keep it like this. That's good enough. We're gonna paste it into here. So now we have GL, this is not GL get uniform though. We changed the top, but we didn't change the bottom. So let's change the bottom there. Okay, then also let's highlight get uniform IV or whatever. Let's make sure it doesn't show up anywhere here, and doesn't look like it. And then glTexSubImage 2D. Okay, so now we'll kind of go through here and see if we've... let's look at for the other places where we're using GL get uniform IV and make sure that we've added the glTexSubImage code in the same manner on top. And it looks like... So it looks like I screwed this up here. So right here I see this as PFN, whatever the heck. That should be a GL, right? glTexSubImage 2D, because we have GL this, GL that. Everywhere else, GL, GL, GL. And then looking up this function name would never work if we didn't prefix that GL on it. So good thing we're kind of going through here one more time. Now the next question is, do we forget the GL anywhere here? So if we do TextSubImage 2D, does it light up in any other spots that it's not lighting up here? So far, so good there. So it looks like GL... Oh, so right here, we screwed this up here. So glTexSubImage 2D, like that. glTexSubImage 2D. Okay, cool. Okay, here's what we're going to do. Once we get back to the top of the file, or once we get to the declaration of the function, we're doing the actual wrapping. So this stuff right here, we're going to look at this right here. We're going to say, hey, does that all look good? And then we're going to go loop through it once. We want to loop through the code at least once and not spot any mistakes, right? We want one full pass where we look at everything and we're like, yep, everything looks good to me, right? And as long as we can do that at least once, then we can assume that we're ready to go. And let's also just look for this. Let's look for this for a second. Okay, yeah, I think that's good. I think that binding is ready. So we added this binding to this file. And we don't need this open. We don't need... We might need this open for reference. I don't know. Let's close this. Okay. So, width and height is already calculated right here. So, it might be easier to... Let's call this dirty subrect, right? Let's shorten that a bit. And this is the calculation for the width, right? So if we take the width calculation and throw that in there, right, this is the calculation for that. I feel like inlining it in here would actually make for a better snippet if we do something like that. So this is width, and then this is the calculation for the height. I want to do something in whatever way kind of like makes the most sense to where it's not confusing the heck out of me. So origin left, origin top, that should just be PBR x0, y0, right? Because it's the minimum boundary. So, we could label this as origin left, right? Let's look at our snippet, right? We got a snippet over here, right? This is the code we're stealing it from. So, we could name this rec width, and then we could rename this rec height. You know, if we want to, like, keep a little connection to this stuff here. Right? So... So this is the dirty sub-selection rectangle. Let's not worry too much about making this too verbose. Let's just let's do what we have to do to identify what we're doing here. So, dirty sub-selection rectangle, RGB integer, RGB unsigned byte, guarantee that's not quite the same here. I'm going to just say, we're going to define this. We're just going to look up what that value is. So, it's not like this... Now, you might say this is a bad idea, but the thing is, these values in the OpenGL library, they're never going to change. Whatever these values are, they're never going to change. Yeah, they're never going to change, as far as I'm concerned. Now, you could say that this is making... You could definitely argue that that is making brittle code. I'm going to say, I'm not worried about it. I think it'll be fine. And right now, it's more about just get this thing working. So RGB integer and unsigned byte. Let's kind of change the formatting there. Let's make it not a ragged right. And we'll figure out what goes in here once we... So we're going to get rid of the G, right? We're going to get rid of the G and just say... right, we're just going to say RGB integer, right? Now, the pixel array, so it says it's an array buffer view, but in our code, it's not going to be that. And the source offset, that's still kind of weird, because that's not in the OpenGL version of the code. This is not an array buffer view. And this right here is the, if we look in, so file open, we go look at pixname .data. The memory we want to push is this tau depot CPU pixel. So let's copy that and just steal that. And say, bam! This is the memory we want. This is the pixels that we actually want to push. So we could say that this is pixel array. That'd be fine. Right, that's pixel array. Format of CPUs to CTS. I'm going to remove CPU side data and just call it CPU data, just so that this commentary kind of fits. And org left and org right, right? We're going to fix that. So it's just going to be, it should just be this, right? So we should just be able to do .x0, right? And let's just keep with our habit of adding way too many parentheses. Right. So org left, org top, and then we got the rec width and the rec height. So we might want to just say, put some arrows there or something. I don't know. And, you know, if we're good about this, oh, that all fits. Kind of dense, but it fits. glTexSubImage. So for texture 2D, say, oh, hey, welcome back. So I'm just filling this out and doing some things that are kind of ill-advised. But, for example, I'm just going to figure out what these are in the OpenGL header. And I'm just gonna hard code them right here. Now, my justification for that is that I don't think that these values are ever going to change for the OpenGL library, and I don't actually use the OpenGL header in my source code. I just kind of reference the values from the header that I need, and I don't actually use the OpenGL header, right? Because I'm grabbing everything at runtime and trying to be kind of lean about how I do things. And I say lean, but then when we look at my code, it's kind of like super fluffy. So it's like I try to keep my code lean, but then it's also very verbose. So it's like, am I a hypocrite? Maybe, I guess. I don't know. I try my best to be an upstanding programming citizen, but you know. Okay. So let's just create a little checksum here. And let's kind of look up what these things are. And then this thing should be AAC 2020 glebind for GL bindings. So if we take this for a second, as is, we should be able to go in here and go Control F and look for that and be able to find it. And we can't. And why can't we? Oh, because it's glTexSubImage 2D. So it's like the namespace is overkill here, right? So a lot of people in their code would directly use this function name without any namespace. This is the other reason why I didn't want to use the GL headers, because I want everything to be very strictly namespaced, and I didn't feel like I don't want all these functions free floating with a 2-letter namespace. These filthy casual people with their 2-letter namespaces. It's like, man, I just don't feel comfortable with 2-letter namespaces. It's just not enough for me. But yeah, if we take this now and we search in our bindings library, we should be able to find a comment. Yep, so there's the comment right there. So this comment right here is just showing us how we're going to use the call, right? This dot that. And I intentionally put that comment there so that it would be kind of very easy to find it in the bindings when I'm looking for it. So it gives me a little sanity of mind that, yes, indeed, this is the way it is, because I'm not doing anything within any IntelliSense, so I have some weird habits, because you definitely develop some weird habits when you're not using IntelliSense, right? Because you have to you have to compensate for that lack somehow, and so that's one of the ways. So texture 2D, we're going to remove this G from texture 2D. And now we're just going to look up what these things are, right? So if we're lucky, and I don't think we are, we could try this. Do I have a shortcut for that? Nope, don't have a shortcut for that, and I'm going to guess I don't have a shortcut for this. And so we could make some shortcuts for that when we find it, so that next time I don't have to dig around in any documentation. But let's look for, should be in like GL core. So if we go GL core URL, we can probably find a URL for the GL core library. Yeah, so, or not library, but the header. And let's put this over on this side. And, oh, what the heck? Okay. And let's just look for texture 2D, see if we can find it. So GL texture 2D, is there any? It looks like we have more than one. 0DE1. Oh. So we got all these things, but this is the one we want right here, right? This one right here. So copy that. And we'll just paste it there. And then we'll take this note here and we'll put it into our shortcut. So I'm going to put that in my shortcut. So oh, do you just realize the madness that I'm doing? You're like, nope, noping. Yep. So yes, if they ever decide to change how OpenGL works and change these hexadecimal values, then I'm in for some serious trouble. Yep, exactly. Exactly, yes. Yes. No, you are right. You are right that what I'm doing, but yeah, so I am living dangerously. I don't know what to tell you. Right, yeah, so if this header changes, right, if this header file changes, then we're in serious trouble, right? So hopefully our unit tests will catch us when things explode on us when they come out with a new version of Windows or whatever. But let's get it working, and then just pray that bad things don't happen in the future. So also here we can you know, here we can I got you. When I come back to this code in a few years, because it's exploded on me, I'll I can refer back to you, be like, there, it's fixed with the comment. Well, it's not fixed, but there you go. So, RGBA integer, let's go look for that now. Okay, and also, right, I could easily mess this up by accidentally transcribing this improperly as well. Because one of the advantages of having a symbolic value is that you can just glance at it and you know it's correct, right? Whereas with a hexadecimal value, you know, I can't just glance at this and immediately know it's correct or not, right? And if you include the header, you have a little bit more sanity where you can be like, yep, I'm pretty sure that's correct, right? Whereas when we're looking at this, we kind of just have to convert from atheism to become more religious, because we're going to need to pray. Okay, so let's look for unsigned byte now. So we got these different unsigned bytes, but I guarantee it's this one right here. I say that as I do things that I shouldn't be doing. So let's copy that and paste that into the code. And then I'll put this in my notes as well. So, okay. Okay. Alright, so now that we have those numbers, those magic numbers, another thing we might want to do is just wrap it like this. Might help us, might not. Okay. So what's next here? So we got these things. We think that we have all the values for this API. And maybe if we're lucky, we just get it right the first time, everything works, and we have some keyboard controls that work. So let's look at these numbers one more time and double check ourselves, because if we get this wrong, we're going to be in trouble. 8D99, and then 0DE1, yeah, so that's correct. Okay. So let's just close this and try to compile. I don't even know if this will compile, because we've kind of mucked around in a lot of stuff, so I'm not sure Also, I'm going to do like a little... Do I want to do a little... If I put a little printf, we could possibly flood the console. I don't know. Let's just try it. Blah. I just want to make absolutely sure that this command is actually getting executed. I wrote all of this code quite a long time ago, but I wrote tests for it and all that good stuff, and I just left out the actual texture push. So like I ran it with a dry run that uses the CPU side memory. So I'm hoping that that we'll get something here, but I don't know. So also I got the rotation in place to work earlier, so I can show you the rotation in place stuff. I could actually show you that pretty. Let me get this working first, and then I'll show you that. Okay. Let's fix all our syntax errors, and then I'll show you the rotation in place. So that looks like it's going to compile. So it's going to compile, but will that command actually work properly, is the question. So I believe by now, since OpenGL is working, that if my fetch of that function pointer had failed, we'd already be crashing. And I see that there's some blah blah. Ooh, there's a lot of blahs going on here. So that tells me that oh, you know what? That's probably for the I don't know. I'm worried about that. Anyways. Okay, so Y and N, right? Y and N. No dice. Okay. So, I don't know, there could be a lot of reasons why this isn't working. One of them could be that our texture push isn't working, right? So I'm going to close this. And I'm going to rethink my life. Also here, let's, I don't think this has it in it, does it? Oh, it does, so yeah. So right, I got the rotation working, and the rotation in place. So the left side, right, so if this were a proper corner tile, then we would want to rotate all of these by 90 degrees to get the next corner tile. Then we would want to once again rotate by 90 degrees again to get the bottom right corner tile. And then once again we would rotate by 90 degrees over here to get the bottom left corner tile, right? So I tried this out, and it got more interesting results. Yeah, it got so, yeah, it got some interesting results. I decided not to do any more of this pre-processing stuff because I think you could really get down a rabbit hole with this, where you're like, you just keep on trying to find ways to like auto-generate tile sets, and there's really no magic bullet for creating artwork, if that makes sense. You really have to garbage in, garbage out kind of a thing. So at some point, you got to have an actual artist in your pipeline, in your engine pipeline. Your engine pipeline needs some type of human intervention at some point to actually get anything decent out of it. And you can try to make a whole bunch of tools to automate that process, but in the end, you really need an artist. Now you could say, well, oh, we can make computers generate awesome patterns. Well, can you? Oh yeah, machine learning algorithms, but they have to take humongous data sets before they can do anything meaningful. So that's not really saving work. That's also a pretty heavy-duty setup you'd have to have. Not as easy as just compiling a little script. And then maybe eventually we'll have like deep AI and whatnot. But as far as like making interesting patterns and things, the human brain is kind of the best tool for that, not a computer. Okay, so things aren't quite working for us, and I think that this code might actually need to be in a different place. So don't we have something called, if we open up the C11 file, I believe we have something called pixel push, right? So pixel pusher and pixel load, and pixel pusher was for pushing up to the GPU, if I recall correctly. So if we go find pixpush.f, I'm going to guess there's one function in here, maybe. Get sampler. This is not what I was expecting. Oh, that's right. Okay, hold on. Oh, no, here's the upload texture area. So, upload texture, but this is a... So we have like a full texture upload. Here. Okay, so I just remember, though, that we have to not forget that OpenGL is like a state machine. And I even have some commentary of, like, before we push up to wherever we're pushing, we have some, like, active texture, bind texture, this kind of stuff here. I'm gonna guess that some of this stuff, I don't know, probably matters. Yeah, like, row length, like, all this stuff that's being called before that texture push, I'm gonna guess that kind of matters, right? So, so we have to figure out, man, I don't want to do this stuff. Yeah, but all this stuff probably matters. So, let's, we gotta steal this stuff here. Because that's probably a big part of why the code doesn't work. So, let's just assume that these bindings are correct, which is a big assumption. But I'm going to assume those bindings are correct because usually if I get them wrong, I have things crash on me. So, I want to assume that part is correct. And, god damn it. So, my text editors like to think that if I have only one tab in here and I try to move the tab to another editor, it closes the previous editor. And that's not the desired behavior at all. Because now everything's closed on me. So now we gotta go here. Okay. So this stuff in TauSync functions. Okay, let's find where we're doing this. I'm gonna make a note of this. Okay. So text sub. That might be a problem, yeah. Okay, so this thing here. Before we do this, I'm pretty sure we need this kind of stuff here. So, yeah. So we need to kind of prep this first, so... Okay, so... So first of all, we need to make sure, well, is this a actual binding in the library, or is it, if we look at our GL bindings, can we actually find that? Okay, we do have that, so that's good. It looks like something very old, because everything's scattered all over the place. So we can go, like, glbind, AAC, let's just say, actually, let's just say... Just call it GB. Hold on, let's call it GB. .gl active texture. GB.gl bind texture. GL pixel store whatever the heck. GL pixel store whatever. And let's just define GB up here. So define GB, AAC 2020, glbind, so that we can kind of find it, right? So glbind, okay, so let's do more of this stuff that we're not supposed to do. So let's go open up a browser and go search for these values here, right? So, let's look for GL core URL. Let's go find texture 0, GL texture 0. Now, if we're lucky, we already have a texture 0 in the bindings, and we don't even have to do that. I don't know if that's true, though. We can try that, though. So if we look in our bindings file, which, if we look for texture 0 here, yeah, we have, like, GL texture here. Uh-huh. 84C0. 84C0. So let's just define this. Texture 0. So GL texture 0, right? Okay. This is GL texture 2D. Let's go look for that. So GL texture 2D. Right here. Copy that. Let's just do T2D. We'll say that's glTexSubImage, right? And then we'll change this right here to texture2D, T2D. And then we can kind of figure out what this texture slot is eventually. Unpack alignment. So let's look for unpack alignment. We're just going to throw this all in here. Unpack alignment. Hey. Okay, so this is unpack alignment. And ALN, const ALN, alignment is 4. I don't know if I really like writing it like this, and I'm not sure how I was able to write this without a type in front of it. Oh, because this was originally JavaScript, okay. So this could be like int32, alignment, ALN, or ALN. Let's just make it a little bit different. Alignment, and what else we got? Unpack alignment, unpack row length. So let's look for unpack row length. Unpack row length. So this value right here. So let's just define unpack row length URL and unpack row length. So 1, 2, 3, 4, 5. So 5 things in here. And we still have some things in here. So we got like pixel width. I don't know what that is yet. Actually, that should be 512, right? So it's the stride. So we're gonna hard code. We're gonna hard code the width as well. Let's kind of put this in here like this. Let's try to. So pixwidth. Right, pixwidth is right here. So you can get rid of this commentary here. Let's give it some room to breathe, so it's not like so claustrophobic. Let's number this. Just enough space to fit all that in there. Okay. Let's go down to the bottom of this section and undef all this stuff. Okay. So this is the OpenGL bindings, so GL bindings, glebind, unpack alignment right here, URL for unpack row length, texture 0 plus the texture slot to get where we're going, texture 2D with the texture handle, and then this like PW, whatever this is. So PW is the pixel width, and it's a 512 by 512 bitmap, so therefore pixel width should be 512. And we're going to hard code that because the whole engine is revolving around 512 by 512 textures, and if that ever changes, we're just out of luck. So We've committed ourselves to 512 by 512 textures for everything. I know that sometimes doing like a mega texture is a better idea. I'd say, you know, after we have something that works really well, then maybe we'll figure out like how to do a huge overhaul to use one gigantic texture, maybe. But for now, it's just easier to have everything compartmentalized in separate 512 by 512 textures rather than using some huge texture. So that's the way we're going to do it. So I know people sometimes complain about like bad performance when they use multiple textures rather than one big texture, but I don't know. I mean, at least I'm using textures that are a power of 2. At least I'm not doing anything stupid. But yeah, so now we need the texture slot and the texture handle, and we could find that pretty easily. So we can go into PixName and look in the data, and we have something that says, hey, this is texture slot or text slot. Hey, that seems to be the exact same name here. And we also have a thing called texture handle, and it looks like yes, powers of 2, fast. Yes, exactly. Especially for graphics cards. Now this texture handle thing is kind of scaring me, because why did I decide that it was like, this is nonsense? Why did I decide to do this? Like it works. It works. The way I wrote this works, but it's like, why? Why did I do this? So uint32, and then this syntax. Like, yes, technically that's correct. It's technically a integer is an array with one element, right? Technically, it's an array with one element, and therefore we can use this initializer syntax, and that is technically correct. But when you're skimming over it, like, my initial assumption when I looked at this code was like, oh, these are some objects, right? Because I look at these and I see this right here, and I'm like, these are objects, right? And now I'm paranoid to change it because I'm making too many changes to the code. So let's so now, is this set anywhere though? Is this set anywhere? This has to be set somewhere, because the texture handle is definitely not zero for sure. Oh, cancel. Where are we searching here? Okay, yeah, let's search in a more reasonable place here. I'm looking right at it. Oh. Wrong thing. Okay, now. Uh-huh. Okay, so this doesn't make any sense. I'm gonna guess we're doing it here, right? So texture handle 001 is the PAINT5D texture handle, and we probably are somehow assigning it. Yeah, we're somehow assigning it. Got it. So texture handle is something we get after we set up the texture. Okay. So let's just do this, right? So we're gonna say we just go like define text lot. Well, we have enough room for it, so let's do it. Define. So the texture handle is this. Texture slot, texture handle. Oh, and by the way, this is the wrong... This is the wrong... wrong memory. I've been working with PAINT5D for a while, so it's like force of habit, but the memory that we want to use is tau depot. Now, do we also make that mistake here? Tau depot, nope, pix name tau depot, CPU pixels. So yeah, if this is actually what we need to run before calling glTexSubImage 2D, I'd say that is a substantial amount of difference to where, yeah, so let's just try to get this working and see if now we can get this code to respond how we want it to respond, or if we're gonna, or if this is gonna be like one of these things where we have to like search for it forever. Unknown type int32. So let's fix that for a second. So int32. So let's just let's put int32 right beneath u32. Define int32. And while we're at it, we might as well take the time to write like a nice little checksum here. So write a little nice little checksum. And then we might as well undef it exactly as it's defined and kind of rebuild this to make absolutely sure this checksum matches. Okay, so texture update subsection. This says GPU sync. Oh no, this is the GPU syncing algorithm. This is just the actual texture push that the GPU sync uses. Okay, got it. Okay, yeah. So pixel bounding rect, which is also known as PBR, aka PBR. Pixel bounding rect, also known as PBR. It's all over the place here. What is all this stuff? Out of bounds. Oh, making sure that it's not out of bounds before we try to push it. Okay, got it. Alright, so we're ready to try this again, and we're ready to try it again and hope that this is just what solves it. Right, so this is kind of why I wanted to read some other code that I had written previously, because the hope is that if we just look at the code we already wrote and kind of cut and paste from code we've previously written, that will be in good standing. Now, that doesn't guarantee anything, but that's our hope. So let's hope, and so Y and N. No dice. Okay, so no dice. So there's a variety of places where things could be going wrong. There's so many places where this could be going wrong now, it's not funny. So one thing we could try, really quickly, so let's close this. So we need to diagnose where the problem is coming from. So we wrote like all this kind of texture push code, and it could be that this texture push, there's something wrong with it, right? That the texture push itself is not proper. So here's what we're gonna do. We're gonna do void yes. Okay, we're gonna break this up a bit. We're gonna say void AAC 2020 tau sync, and then we're gonna call this one by the actual name here, which is what is this called? This is the glTexSubImage 2D. And then we're going to give it this rec pointer, pixel bounding rec, aka PBR. And we're going to throw all the code in there so that we can, and we're going to do that so that we can swap it out for something else. Right, so we're thinking, hey, if we didn't get this right, maybe we can do something else that can verify if that's the problem or not. So we're going to take all this code, and it looks like we might as well kind of like keep this boundary thing here, since it's kind of like we cut and pasted it so the indentation level got changed. We might as well just relabel it like this and just say, hey, you know, just keep the same label. Sure, why not? Alright, so now we have this label here and here, but it's also here and here where we extracted it from. That's fine. I think that's fine. So let's take this and make sure that the code still functions properly, right? So if we extracted that and now we call it from here and we use PBR, does this still work properly, or did we break something with our simple refactor? And if we didn't break it, what we're going to do is we're going to call a different update function, one that kind of pushes everything, and just try to push the entire texture up. Like maybe it's going to be inefficient if we push the entire texture up, but maybe we've done something stupid, and so we need to fix that. So okay. Now, so this pixel pusher has a way to push up so here it is pushing up PAINT5D. We should have something for Tau Depot as well, shouldn't we? Yeah, here we go. So, since we already know that this kind of pushes up the entire texture. This right here uploads the entire texture. But that's a good way to say, to kind of figure out if where the problem is, right? So if this actually fixes it, we know that it's our remove once working, and then we'll okay, so if the problem is with this new command we wrote, it's not doing it the things it needs to do properly, then this command that pushes up the entire texture will yield results. Okay. So let's do P for whatever, and then Y and N. So it looks to me that that the problem is not. It looks to me that the problem is not the texture upload, right? Because we're seeing the same thing here no matter what. So the next thought is that I think I didn't wire it up correctly in the first place. So when we use the P key, I think we use the tau memory. The tau hold on, so you'll see. So in PAINT5D, so if we look at how this is done, I think we're not accessing this correctly. Or actually, no, that looks about correct. So get and put tau PAINT5D system AD. Okay. And then if we look at the shader code, and if we look at the shader code, don't we have... If we look at the shader code, we should have... So when we're looking for where we're using tau for a second. So right here is where this new code, PixDex, get U32. So we're sampling from this texture. So one thought is that the math is just wrong, right? So the math would have to be exact. So that the math has to map exactly to that exact pixel, and if it doesn't, then it's going to blow up in our face. So that's one thought. So there's a lot of things that we could have screwed up here. And then also when we call this get U32 that we made, we could have got those numbers wrong as well, because we hard-coded some stuff in here. And so tau is 015, we're using this. Subsystem is PAINT5D. And 8 is the AUS DEX. And that's the same thing over here. Well, let's actually look at the actual values, though. So let's close this for a second. Let's close this. and PAINT5D offset DEX. Where is that going to be? I think we're getting kind of tired here. I just wanted to do a little bit of work today. Let's... That's going to be in here. And if we look at these diagrams, right, tau 015 is the only valid option here. PAINT5D is 1 here. So we have subsystem tau depot, subsystem PAINT5D, and then subsystems that don't exist yet. So PAINT5D hardcode is 1 here. That makes sense. Now 8 for the offset DEX. 8 is offset DEX right here. We can see it hard-coded right here as an 8. And the idea is we're going to get rid of this hard coding after we get it working. It's just that we want to eliminate some moving parts before we code it properly, right? We want to just get it working first, and then we'll fix it. So P5D 80, and that's 8. Okay. And if we look at how we use it, we use P5D80 right here, we use PAINT5D, right? We do all that stuff, right? So what we might want to do here is this is the keyboard bindings that we're trying to use. So why not assert that, 15 equals this thing here, right? Let's assert all of this stuff. So PAINT5D... Let's absolutely assert that this is correct. So 15, 1, and 8. Right? So we can make a note, right, that this is at vid IID 0132, and the time is 2:22, and we're about close to 42, so let's do 42. Right? And we just want to assert that all these are correct because we have this 15, 1, and 8, and if it's correct, then this 15, 1, and 8 should work as well. Trying to get AUS DEX to also, another thing we could think of is, do we even have this in the shader code? Do we change the shader code recently? So if we look at this F5, if we look at this, does it even have the new code in it, or do we not remember to delete the old shader? And it's like we're trying to get this code working, and it's not even in here. That might be a reality. We might be trying to, like, diagnose the problem, and the problem is that this function doesn't even exist in the shader yet because we haven't... Oh, no, it's right here. And are we calling it yet, though? Oh, but we're not calling it yet. We haven't even started to call it yet. Okay, so one of the problems I'm seeing is we have not even... implemented this yet in the code because we didn't delete the old shader. So we could be looking in all the wrong spots right now. So let's fix that. Let's delete this. And we might get some syntax errors if that's the case, because that means that we haven't compiled this in a while, and it might just be that the shader was out of date. So let's see. We might luck out here. We might not. We're about to kind of find that out. Okay, so we have a syntax error. I mean, that's not the... That's good. That means that... Oh, a syntax error is not good, but at least what that means is that... it means that the shader code we wrote was not actually getting ran, and because of that, we weren't seeing what we were expecting to see because, well, we have a syntax. Yeah, it was never even being ran. So let's see if we can find what that error is. Implicit cast from uint to int. So that's a pretty common error I get. So let's go look for that mistake. So the scary part is, you know, where could this be in the code? So we added this right here, and this is get u32, 15, 1, and 8, and this is expecting, oh, you know what, get u32 AUS DEX, and then AUS DEX right here, it's right where, it's right there for us to see. AUS DEX, okay, here's what we're gonna do. So we already have code that's like, hey, I take int32, right? Like all this stuff takes an int32. I don't want to have to deal with the problem there. So let's just change this to get i32, and then. Actually, let's not do that. Let's use get u32, and then let's just make a u32 AUS DEX u32, and then AUS DEX u32 will equal this, and then AUS DEX, which we want to use, equals make int32. And we're going to take the AUS DEX u32 and we're going to plug that into there, right? So so we're still going to get the u32, AUS u32, get it. Then we're going to make it into int32, make that u32 into int32 and put it into here. And that hopefully will get rid of our casting problem. So let's delete this shader. Okay, now that the shader is deleted, let's delete this. Okay, let's give that a run. So I'm hoping just to get this working. Once I can get this working and I get some feedback, I'm gonna call it a night. But I want to get this done first. So let's hope that we've gotten rid of that syntax error and everything looks good. Because okay, good, kind of good. Well, we've taken a step back. Something has blown up on us. Okay, so now the question is, what is our data set? Why is it looking like that? What did we break? That sucks. So let's open up PAINT5D.png really quick, see what that is. Okay. That's fine, but it's not supposed to render like that at all. Oh, wait. If the offset DEX was that's the thing with no that's actually what it's supposed to look like at the lowest offset level because of the blank alpha. Oh, okay, actually, wait, no, let's give that another run. That actually might be correct. Never mind. I thought everything blew up in our face, but that might actually be, it might actually be working. It might actually be working. We just have to go press Y a few times and see if we see any changes. So, my bad. Okay, so let's go over here to, let's press the pattern key. So P for pattern, and let's hit Y a few times. Ah, yes. Okay, we are, yes. Excellent. So, I think it's also about 9, which is drug time, so it's like time to do drugs anyways. But yeah, so now we can go through each one of those cross sections. Yeah, so, this is the full 16 tiles that, wait, right? So this is the full 16 tiles, the full 16 tile sets that are encoded in AUS, right? So when we're going through here, we can use the keys to like loop through these, and we can see all the different cross sections, right? So the beginning cross sections are just a big chunk of white because there's no variation, right? The alpha channel is just 100% everywhere, and then over here, right, we get this, we get that, right? All these different cross sections, and then very close to the tippity top, we have the weird scary face, right? So here's weird scary face here, and then here's the last one. Oh, so oh, crap. Hold on. Does it delete my chat when I do that? Do I lose my chat? I know what you said, so I'll respond to it, but I didn't mean to go off of the chat. Come on. How hard is this supposed to be here? Oh, man, I lose my chat. Well, I know what you asked, so... oh, there we go. So... yeah, so what you're seeing with those two squares is it's outside of the camera. It's outside of the camera, and I did not write any code to determine what happens when I try to render outside of the camera, and anything happening outside of the camera right now is undefined behavior. Now, I should kind of clean up the code, obviously, so that I don't get any weird artifacts outside of the edges of the camera, but that's why you're seeing 6 squares. It's because... and you can kind of see that if you look at the render, right? This and this square exactly match this and this, right? So it's only these 4 squares we care about. This is actually outside of the camera area. And why is it only these 2 squares and not these 2? I don't know. But the thing is, it's outside the camera, so it's undefined behavior, and I'm not going to take the time to contemplate why it does what it does, because there's nothing that I say that it should do over there. That's just the way it is right now. So we're just gonna say that's what it is. We can clean that up later, but right now we're just like trying to get the basic renderer working, and then we're gonna polish that up eventually. Okay, too complicated to get it. Yeah, or something like that. Yeah, but yeah, so yeah, I don't know what's going on over there, and it doesn't matter. Now I'll clean that up eventually and get rid of that artifact, because that's a pretty big artifact, seeing that the artifact is, you know, 1/3 of the image you're seeing on the screen is artifact. That's pretty significant, right? Now let's cross our fingers here for a second, because in TauSync, right, we decided that remove this once it's working and then comment this back in, right? So there's still the possibility that what we've written, yes?
Break time.
Yep, I got it.
Meeting time.
Oh, yes, I see.
Yeah.
Okay.
Not getting out of that one.
I see. Okay. Okay, so.
Take a quick, 30 minutes.
It is family meeting time, so I must go for what should be a small amount of time, but
half hour
I am
max.
skeptical.
Half hour max.
I say half hour max.
After half an hour, I will let you dip out. They can probably hear me.
Yeah, they can. They can hear you. They can see you. They can see me typing, and I'm chatting to them.
They can't see me.
Yeah, they can see me typing.
They can't see me.
They can't see you?
I hope they can't. I'm only in my boxers.
Oh,
hey, dude. You're back.
yeah.
Nice. Alright, come on.
Alright, sounds good.
Let's
I'm
go.
gonna put a little... I gotta put the brake timer on. Gotta put the
Alright.
brake timer on. So, brake timer. Where's my brake timer?
Where's your brake timer?
Brake timer.
Are you actually gonna put the brake timer on this time?
I'm putting the brake timer on right now. I always put the brake timer on. I don't know what you're talking about.
No,
Not
the
putting...
last time I saw you put it on incorrectly.
No, I didn't. I put it on totally correctly.
Totally
You're
correctly.
making up lies.
For sure. I'm making up lies.
Lies and slanders.
I'm lying. Through my teeth.
I'll put it for 36.
That's probably safe.
But that's just to account for the time it takes to get upstairs.
It takes 6 minutes to run up 2 flights of stairs.
You'd be surprised. Come on. Okay, let's
Come
go.
on.
Oh yeah, my girlfriend said, oh, it doesn't take 6 minutes to get upstairs, then explain how my timer was going off when I came down here, because we set the timer for 30 minutes before the meeting started when I came upstairs. Buzzer went off, turned off the buzzer, came down here. So 6 minutes actually comes and goes really fast. Like, to walk upstairs and walk downstairs, that actually does take like 3 minutes if you're not like dilly-dallying at all. And I don't know how long that was beeping for, but yeah. But yeah, maybe don't listen to people's advice and how long things are going to take when they're not the ones who are meticulously timing things every day. I'm the one meticulously timing things every day. I know how long things take. Okay, so let's try this and see if this command will also correctly compile. Now this is working on the CPU side code, so we don't have to recompile the shader to get that work to see if that's going to work correctly. Though I guess maybe for, you know, the sake of, it's not too hard just to delete this file anyways. So for completeness sake, we might as well delete the shader file, you know, when you recompile. And if this, if we still can get the keyboard controls to work, then we can be pretty certain that our texture push is working correctly. Our sub-texture push is working correctly. So let's do this, and let's do P for pattern, and let's do Y to move through here and see if we're getting anything. And it looks like, to me, it looks like no. It looks like to me that the sub-texture pushing is nope, no dice. So I'm trying to go through the texture P, so that could mean that we're just looking at the wrong pixel, that the math for the texture push is wrong. So this is not working, right? And so if we put this back in here for a second, right? So if we just put that back in and we try to run this, right? So this is going to re-upload the entire texture rather than a portion of it. And this seems to be working. So if we do that, and then we try to take a look at this, right? We go over here, and we press P for pattern, and we go Y to go up. Yeah, that works, right? We can actually go, we can go up and down through the data set, and we can see stuff, right? So it's not my imagination. That texture push command, there's a few things, right? Like, either it's not working, or, well, it's not working. I mean, not working is pretty vague, right? So of course it's not working. Something's broken. As far as what is broken, that I don't know exactly what's broken. There's a lot of possibilities as to what could be broken. The best possible case scenario as to what is broken would be that the math for the math in the shader for what we're sampling is wrong, right? The pixel we're sampling according to the shader logic is just wrong, right? That would be the best case scenario. But yeah, I can see. Yeah, so that's kind of interesting. I guess the next thing is try to figure out how to fix that. And also, yeah, I think that's the next thing we want to fix, is figure out like why that texture push is not working. Possibly the texture push is working, and it's actually pushing up correctly, but the pixel that it needs to sample is incorrect. Well, actually, no. Hold on. No. Because if it were sampling... So, if it were sampling... If the problem was that, hey, the code is sampling the wrong pixel. If that were the case, then we wouldn't even see this, right? We would not even see this if we were sampling the wrong pixel. So then that comes down to, well, the texture push is not working correctly. That would be the other possibility, right? That the texture push is not working. So when we're looking at this code here for this texture push, let's look at how we set up that call. So we did this active texture, bind texture, pixel store. We have this alignment thing for. So the pixel width here, that looks suspect. So like, is that really supposed to be 512, right? Like, is that really what it's supposed to be, or is it supposed to be some type of other offset? So if we go in here for a second and look for pixel store, whatever the heck this is, and see how that is being used, and then also read about it, right? So pixel store, so this is the alignment, and then we have another one, row length. Unpack row length. And we have pix width here. So I'm going to guess that pix width is taucon, whatever the heck, right? All this indirection really sucks, because now we got to be like, where is this, right? This is like, is that pixel width actually correct? And I don't know if it is. I don't know if... Let's do backwards direction. I don't know if that pixel width is actually correct. So this is saying 2048. 2048, that sounds a little bit weird. That kind of sounds like, does that not sound like, I don't know, that sounds like 512 times 4, doesn't it? 512 times 4 is what? 2048. Okay, okay. So it's saying the pix width is 2048. Now, are we actually allocating 2048 by 2048, or unipix dexhot unipix.pixwidth so we see pixel dex, pixel width, well, here's a pixel width, and then here's a component index. What about this pixel width? So this is saying the unipix is 2048 instead of 512 by 512. So yeah, so we hey. Hey. Anyways, yeah, like, yeah, it's, yeah. Anyways, family meeting. I left after my buzzer went off. I went upstairs, turned off. I set the timer for 36 minutes before I walked upstairs. Walked upstairs, set the kitchen timer for 30 minutes. And then when the kitchen timer went off, I turned off the timer. So I walked into the kitchen, turned off the timer, and then I came down here. By the time I came down here, my alarm had already gone off. I have no clue how long my alarm was going when I got back here, but it was already going off by the time I got here. So that's telling me that I wasn't wrong saying 6 minutes. And 6 minutes is usually, like, if I need to, like, go upstairs, boil some water, make some tea, and come downstairs, usually takes about 6 minutes to do something like that. It might seem trivial, but when you're recording yourself all the time, you realize how much time you can waste just by getting up, where it's like, you think, oh, I'm just gonna, yeah, that's fine, yeah. So it's like, I don't know how long it's gonna take to, yeah, like when you time yourself, you realize, holy crap, just the act of getting up to do something else wastes an incredible amount of time. And so if you're getting up, you better be okay with wasting time, because you're going to waste time. Like I have wasted large amounts of time by just trying to run around really fast and do something. I have spent yeah, everything takes more time than we think, totally. Like, it's not just programming that takes more time than we think, it's like everything. Like, I have taken, like, you know, 30-minute breaks where it's like, I literally run to do one thing, run to do another thing, and I literally, not walk, I literally run around the house to do different things. And, yeah, exactly, project time estimation, exactly, yeah. Yeah, but I have literally done things where I'm just, like, running around the house, trying to do everything that needs to be done, and yeah, and I still don't have enough time. So, I need to see what this pixel store thing is, and figure out what, specifically the, unpack row length is doing. Now, I assume the row length would be 512. It's always 10x in general, yeah, one order of magnitude makes sense. So, I'm going to take a guess that the unpack row length might be in terms of components rather than pixels. That would be my guess, right? So, if we do, like, unpack row length, and then we take this and we cut it, and then we paste it into here because Torch browser is shit, and despite telling it that we want to use Google for our default search engine, it's like, oh, buddy, so you want to use Google up here, but it's just still going to have the default landing page to some other search engine? Yeah, unpack row length. Well, unpack row length in terms of WebGL might not be the same thing. Number of pixels in a row, right? Yeah, so that was what I was assuming. The other thought is that the sub-image needs a... So when I use the, let's go into this code here. When I use this command here in the WebGL, there was an extra parameter that allowed us to specify an offset. So it's like, you needed to specify the rectangle, but then you needed to also specify a stride offset, or like a seek offset into the data. Yeah, and there's no such thing here, so that does make me wonder if there's some other parameter we need to set up to properly use this. So we know that we're fetching the pixels correctly when they are uploaded to the GPU, so that leaves this kind of texture push, this sub-texture push. I don't think we're doing it correctly, and we gotta figure out, like, well, how the heck do we do this correctly? glTexSubImage, X offset, Y offset, level, height, format type, blah blah blah. Texel offset, texel offset. So texel offset, basically a pixel offset and a pixel offset. Oh, yeah, yeah, Java. Yeah, so this is desktop code. The idea is that I'm cross-checking my code against the JavaScript codebase. I'm cross-checking my code against code that already works, right? So it's like I can look at the documentation and say, oh yeah, this is how to do it. But I'm pretty good at screwing things up by just doing them from the documentation. It's better to have like an example piece of code that's already inside of a working system where you're like, this piece of code, I absolutely know it works, right? Because if we get certain, right, anything we get wrong is going to screw us up, right? We get one thing wrong, and it's not going to work at all, right? So the idea is just to cross-check it against code that we've already written. So I'm kind of cross-checking it against the WebGL code, right? So right now we're in the OpenGL documentation, but then over here I'm cross-checking against some JavaScript WebGL code here, right? So like object.cl, for example, that's JavaScript, right? So yeah, pixel store modes affect texture images. glTexSubImage 2D and glTextureSubImage 2D to specify two-dimensional subtextures for the current texture unit. Specified with glActiveTexture. Okay. So what I could do is I could check for errors, because it looks like we will get an error if we fail here. It looks like we're gonna get an error. We're gonna get an error code. So the next thing we could do is see if we're calling this correctly, right? We could just throw in I think glGetError is what we need to do. So right here we have glTexSubImage 2D, and we could do a AAC 2020 glbind glGetError. Should be called glGetError, I believe. We can do a quick check on that, right? So if we do find in files and we look in our code base, if that's correctly spelled, we're going to see it pop up all over the place. Yeah, glGetError, and then error is what is the type of error? Let's look at that for a second. Error is GLEnum unsigned int, so it's a U32. Okay, so good enough for me. So yeah, right here we could just say let's just do this, because U32 ERR equals so if error is not equal to 0, then bad times 2021 A. Okay, then let's do the same thing after the call, right? So after the call, let's do the same thing, and this will be B, right? So we got A and B, right? So let's just do that as a quick sanity check. So my assumption right now is that we are indeed using this function call improperly, and that's why it's not updating correctly. Now, the other thing could be, if it's not that, the other potential problem is if this doesn't actually get an error, then the other potential problem is that we are... Oh, also we have to call it, right? Hold on. Hold on, we're gonna have to close this for a second. Here's our texture push. This is the push of everything, which is working for us right now. And this is the thing that's failing us, so we need to put that in here, right? So our commentary says, remove once working, comment back in once working, right? So, the other potential problem is that the code we're using to find dirty regions of the texture and only push those dirty regions, even though we wrote a lot of unit tests, maybe we still messed up somewhere, and we have to fix that. So, let's do P for pattern, and yeah, P for pattern, O for output, and then let's hit Y. So apparently, if we are to trust the fact that GL get error isn't doing anything, then yeah, okay, well, let's make absolutely sure. So you see this blah message here. Where's that coming from? Is that, yeah, that blah is coming from right here, so we're calling this. Let's go look at what that value is, though. Is PBR maybe just nothing? Or knowing what that value is could give us some help here, right? So, printf, you know, PBR.x0. And PBR.x0, right? So we're gonna... Yeah, we're gonna take this and just go bam, bam, bam. And we're gonna do x's and then y's, ones and zeros. So x's and then y's, ones and zeros, like this. And we're just gonna see if that gives us any insight, right? So maybe we can look at that and see if these numbers make sense, right? So maybe the numbers don't make sense. That would actually be the best case scenario, is those numbers not making sense, because if the numbers don't make sense, it's better the problem is with our logic than having it be the actual OpenGL call that it's not working properly. Like, it's going to be easier to find a problem if it is the R logic and not some other library. Oh, that's because it has to be dereferenced. So let's just do this. I think arrows make things very hard to read. You know, whatever. Let's just get it working. Let's not worry about things are hard to read or whatever. Yeah, but after this, I'm probably going to try to see what those numbers are. Right, and it should be like a one-by-one kind of thing going on here. So if we press Y, so 432, 433, 384, 385. So it should be like a, remember we store everything in a 2x2 pixel subsection of pixels, so it actually makes sense that this rectangle would be a little bit bigger. So 432 by 433, right, is too wide, and then 384 by 385 is also too wide. So that makes sense. So that looks correct. Now I don't know if that number is correct. I don't know if this number is the correct location or not. But that would be the only way. Yeah, I don't know how to, yeah, I don't know if I don't know how I'm gonna fix this right now. It's, so we know when we push up the whole texture that the shader code can correctly target the exact pixel we're looking for. So that kind of tells me that it's this this update logic that's not working correctly. And that's kind of weird because we kind of assumed we knew exactly what pixel needed to be updated, and yet here we are having a problem here. So it's near the so we got like a 512 by 512 block of memory, and yeah, we'll have to write some more test code, possibly. I think I can't help you with this, too gamey for me, yeah. And also, it's just a lot of stuff is going on here, where it's like, it relies on a lot of code I've already written. I think that, yeah, so, probably more unit tests, and we want, like, a unit test to test the very exact case of this specific value, right, to see if that is updating correctly. Because right now, I don't know if it's working correctly. So we want a way to cross-check. We want a way to cross-check that this rectangle actually accurately reflect the piece of data that we want to push up, right? Because if this rectangle is off by 1 pixel in any direction, that would be enough to wreck it for us. If it's off by just 1 pixel in any direction, then we would be updating an old piece of memory. No, we would be updating a piece of memory that did not need updating, right? And that has to be the problem. That the push. Well, that doesn't have to be the problem. Either we're not pushing up the correct coordinates here, or this call that we've never done before in this code base before is wrong somehow, right? So that's a high probability, right? That hey, we've never ran this code before. Maybe we've never ran this code before. Maybe that's the problem, right? I mean, because so left top yes, this would be the top left, these two coordinates here. This math does give us a rectangle, right? The x, the higher x minus the lower x plus 1. Higher y minus the lower y plus 1, right? Because our rectangles are designed to be inclusive. But the other thing is that it doesn't say that we're doing it, we have an error, right? So GL get error is not doing anything, right? If error is not equal to 0, then we're going to crash. And Here, we check for an error before we do this, and then after we do it. And so far, no kind of problem there, right? Now, we might want to do it, we might want to also put this, let's be really paranoid and just put it here as well. Right, like, I doubt that, right? I doubt it, but let's put it here as well, because if, I don't know what we're gonna call this. Let's do it. Let's just call it 001. And let's put it after here. Let's overkill it, right? Let's just overkill, throw it in a whole bunch of places. Because we don't know, right? We don't know. Let's just throw it into way too many places. Generally, you have to call get error right before the function call you want to check. Yeah, you want to make sure that you're in a non-error state before you check for an error, right? You want to make sure that the get error is coming from the actual command, right? So before we call any of the commands, we want to check for an error. Then after, we want to check for an error. But let's just kind of throw it in everywhere, because I don't know. It could be anything. It could be anything. Anything could be screwing us up right now. So let's put this in the middle. Let's put this over here. Let's put one on the outside here. Let's put one here. And, let's, if we're gonna pepper it all over the place, we might as well make a little section for this and be like, you know, crash if GL has error. We might as well make a little section for this, make a little helper function if we're gonna pepper this all over the place, because we're gonna save some lines of code, and this is getting ugly. So, let's take this and say, you know, void, so there's two possibilities right now. There's two possibilities. Either my texture push call is wrong, so that could be a possibility. Somewhere in the texture push code, it's just wrong. The other possibility is that the texture subselection rectangle for selecting the dirty area of the texture and pushing that up, that is wrong. It could be either one of those right now. I don't know which one it is yet. So I'm trying to eliminate the possibility of number one. So I'm trying to eliminate possibility number one by just peppering this code. Texture comes from an image, yes. So the texture, I know the image. I absolutely know the image is correct, because when I push the entire image up to the texture, it works fine. Now, that's not the way I want to do it, right? Because the texture, remember, it's texture as uniform, right? So it's a big texture that's storing a whole bunch of pixels, and those pixels are supposed to be used as uniform values. So it's not going to be very efficient if we change, say, one uint32 value. We change one uint32 value every frame of the game, but in order for that value to persist, we have to push up the entire 512 by 512 texture. I think that's kind of obvious as to why that's a bad idea. So we made a whole system around pushing up subsections of the texture, and only pushing up the subsections that were dirty. Yeah, so I could do that. Yeah, I could do that as well. So, yep. So I could definitely do that. Now that's going to take more work to get in place. Yeah, so that I can definitely do that, and it may or may not come down to that. But that's definitely something I'm gonna. That'll be one of the things I'll definitely try. Right, try to visually confirm that things are going correctly. Now the problem with that is the shader code I have is currently designed to render. It's not meant to render just the texture as is. Yeah. Like, if you don't see all white equals, you messed up. Yes. So, yes, I could definitely do that. The problem right now with that is the shader code is not supposed to just render the texture as is, right? So we would have to write another shader that just renders the texture as is, and we would have to put it somewhere. And now we could temporarily replace our shader code with that shader code, right? We could temporarily replace it, or yeah, there's many transformations, right? Because right now, yes, right? Because our remember, we're never displaying the entire texture, right? We're using the texture as a data set, so it makes a hell of a lot of transformations, right? So remember how when we take this image, not this image, let's go into the assets. So there's no renderer for that image. It's just like there's no renderer for it. So what we could do is we could try to load this into the tau texture, and then do a subtexture update on it, and then have the shader have a setting that's hard-coded somewhere where we hijack the shader and render this image rather than render the tile sets. We could try to do that. But yeah, I don't have anything that's ready to just kind of like render the texture as is. What we could do is we could take the default shader for shader slot 0. Like when you start up the game, it says ready. We could hijack that shader and give it new shader code, and that shader code could be just used to display the raw memory for the different systems, right? Like, it could be like a system inspection. That might actually be a good idea. So, like, you hit key number 0, and it shows you the tau texture, and then you can use other keys when you're, you can use some other keys to kind of like flip through all the memory and inspect what it actually looks like on the GPU, right? So have like a GPU memory inspector. That's probably a good way to go. So I would make a clean, very isolated project with minimal stuff, just to test that function you have doubts. Yeah, so we could do that, right? So we could, now, so yeah, like this, that's a good idea. The problem is getting a clean, isolated project would be, there's not really such a thing as clean. Like, when you think about all the guts that goes into it, like, just to get OpenGL working, like, even if you do it the proper way to get OpenGL working, you have to get a window, right? You have to get a Win32 window or a native window, right? Already that's not clean and isolated. It's like there's tons of crap that goes into that, right? So now you can use a window wrangler library. You can use like glFW to make it simpler, but there's still like a whole bunch of stuff. Like it would not be a trivial undertaking. It's not like, unfortunately, this is not like JavaScript where it's like, if this were JavaScript code, yeah, I would just be like, oh yeah, let's just make a tiny little project and test it out, and I would totally do that. If it was JavaScript, I'd be like, yeah. I am fairly certain that I do not have the ability to just write a simple little project and test it out. Now, if I could maybe hijack, if I could hijack some of the code I already have. So here's something. So let's look at something for a second. So let's look at our build script for a second. We're going to get back to this, but let's look at the build script for a second. So notice that right here we have this thing, how we have this fexdum.c11. We're compiling another executable here, right here. We're compiling another executable, and it's called fexdum.c11, right? And then we create this fexdum.exe. So, well, this is the input, this is the output, right? And we pump it into this GCC command here. So let's take a look at fexdum.c11 for a second, right? So, like, where is that coming from? Well, it's in an exe folder. Okay. So if we go into lib and we go into exe, we see, ooh, fexdum.c11, right? And if we open this up for a second, you'll notice that this would be my best. If I were able to get a small little project, this is probably how I would have to do it. So we're going to take the library code for the main project, and we're going to hijack. We hijack two of the files, right? So you know the libchan where it has all those sub-libraries? We're just going to hijack one of those sub-libraries and compile it as a standalone executable. Alright, so then we have the fexdum has a standalone main, right? So this C11 file is responsible for turning in one of our libraries into a standalone executable. So if we close this, and we go into our main library. So this is our main library right here, right? Yeah, this is the main library. Right, these are all the sub-libraries in the main engine, right? And so we compile all of these libraries into one executable, right? So but fexdum here, right here, it gets compiled twice, right? It gets compiled as its own executable, and then it also gets compiled as a component within the main executable. So we could maybe do something like that, right? Where we try to hijack just the parts we need from this library, right? So we go in here, right? And we go into the, like exe, right? And we create another, right? We have fexdum.c11. We could make like a mini project somehow, but there's still a lot of, it would still be pretty difficult. So that would be my last resort. I think it would be better just to make an integrated feature somewhere in the engine. And I know where I would put it already, so let's just comment this out for a second and run this again. Or not. Oh, we're still running, aren't we? Okay, let's close that. Okay. Yeah, OpenGL hello world plus that function. Yeah, so it would take me a while to get an OpenGL hello world. Like it wouldn't be a trivial undertaking. Because I know what you're talking about. Yeah, just get the texture on screen and then try to do the subtexture push command, right? Just get a texture displayed on screen, then have like a key you can press, and then Copy pasta from the internet? Yeah, maybe. I just think that it will be a big... I think it's... From my experience of doing OpenGL code, I just think it's going to end up being a big time sink. So if I do it, if I copy pasta it from the internet, I'm going to have to figure out how to do the correct, like, build settings, right, to, right, so I have to, like, include the headers and make sure the linker is set up properly and all that nonsense, and, it's not actually that easy. Like, I organized this code base to have a dead simple build system where I didn't have to worry about, the complexities that come with other code bases, just because, like, I don't know enough. But yeah, so there'd be a learning curve where I'd have to try to do it, right? Like, you'll notice that, like if you look at my build script, right, you don't see, in here, you're not going to see any, like, linker flags, right? There's no linker flags or include directories in here. No linker flags or include directories in any of this stuff, right? And if I were to do kind of like the quickest way to get something up and running in OpenGL and C code, I would definitely have to figure that part out. So I have to figure out the code, but then I also have to figure out the build steps, and so I just think that it would take more time. But let's run this for a second. Oh, air is not. Let's just finish this function because it's. So let's just steal this. And I don't know what we're going to call it yet. AAC, it's going to be private, so it's going to be like AAC 2020 tau sync how about, I don't know, GL get air, crash on OpenGL air. Camel case, one thing I hate about camel case is when you mix camel case with acronyms or like, you know, abbreviations like GL, right, then it doesn't look very camel casey. Like if we say something like, you know, crash on GL get air, right, that looks horrible, right, like the GLG, right? And if we take it and we do GL like this, is that even proper? And then that, like, there's no way to do, like, camel case. Sometimes I do, like, camel case does annoy me with that aspect. But I'm going to call it crash on get error. Camel case is cancer indeed. Yeah, so, yeah, when it's not a transformation of data, I just use camel case. When it's a transformation of data, it just ends up not camel case because I just keep the tokens for the variable names the same, and that's why it looks the way it does. But yeah, let's just do void. Let's just get something working here, right? So actually not void, because we want like a const char for the error message. So like const char pointer, and then MSG error. Yeah, message error. So it's a message, and the subtype of it is it's an error message. Is kind of what I'm trying to say with this variable name. And let's steal all this code here, and then rework it a little bit. So it's going to be a U32 error, and error equals this, and then, you know, if error, here, let's try to, sure. Let's open this up a bit. Okay, so let's take this message here, and let's actually printf that. Let's printf. Crash on get error, msg error, %s\n, and let's put that right there. And then, see message. Actually, no. Okay. So we're going to crash, and we're going to say see message above for reason. And the reason is, you know, crash on get error, which is this function here. The message error is this message, right? So we just want a way to be able to trace back to the source of the problem. And then eventually we'll make this more robust, right? Well, if this actually ends up failing us, right? If we actually get this to happen, then within this body we'll actually fetch what the, well, we'll print off what, well, first of all, we'll print off what this number is, right? But for now, we're not going to even worry about that until we can actually get this. Like, if we never get it, if we never get an error, then it does not matter what this number is, right? If we never get an error. Now, if we end up getting an error, then we can refine this a little bit more to diagnose the problem. But for now, we'll just keep it like that. So let's just define U32, and then let's define error. I think that's all we need, right? Define U32 and error. And it's going to be AAC 2020 tau sync halt. Then down here, we're going to undef U32. And then we're going to undef space error. Doesn't OpenGL have something like get str error? It might. Here, let's go look that up really quick. Returns like an error code, and maybe it already has something. Yeah, let's look at that. Get error string OpenGL. Let's check that out for a second. Because yeah, glue error string. So this is kind of telling me that the answer is no, because I believe glue is, well, maybe, let's go look at that. Maybe this looks like a different library. This looks like a library to help with OpenGL, but I could be wrong. GLU. Produce an error string from a GL or GLU error code. Okay, maybe, actually, no, never mind. I'm wrong there. GLU error string, GL enum. Oh, GL unsigned? What the hell is the U for? Okay. So this is, yeah, so you're correct. You're correct. Okay, I'm going to take this. I'll take that, and I will throw that. So, now the thing is, if I use this, I have to create a binding for it. So, but, GL error string. And then let's take your get str error there. Let's put that in the notes. And then we can take your commentary as well, and we can just put that in here. Okay. So, yes. So we can, Google says glut is the OpenGL utility toolkit, a Windows system independent toolkit for writing OpenGL programs. Yeah, glut, and there should also be glFW. Now I don't know. I think it's glut plus glFW. I think, or maybe it is one or the other. I can't remember, but It's either glut plus glFW or just one or the other, because glFW is the OpenGL function wrangler. But yeah, it might be both of those. I don't know. I don't actually write. I don't actually use a library for it, right? So I don't use any library code, right? I pull the function pointers for OpenGL using like load library and get proc address. And I don't use any of the OpenGL headers, so I don't really know. But yeah, if you don't want to write native Win32 code, then you would either use like glut or glFW. I guess I don't remember which one's which, but yeah. So where was I? I'm getting kind of tired. I wanted to wrap this up, but before we wrap it up, we actually have to get to a stopping point here. So this is fine. That's there. Okay, so we have this crash on get error or whatever. So the next thing we're gonna do is say like we have this error thing. Let's just say define crash on error. Right? So crash on then here undef. Right? So crash on error, COE, crash on error, and yeah, are you talking about the libraries? Because it gets complicated, right? So it's like, there's no way to escape the complication. Like, you try to abstract away the problem, but then all you end up doing is like, oh my god, how do I do this in this library? How do I do this in this framework is what you end up with. So you can try to use a library to make your life easier to help with the fact that you have to wrangle a window, but you don't really, I don't know if it really helped. Maybe it, highly opinionated here, but my thought on that is a lot of times you try to use a framework to help you like solve your problems and simplify your life, and then what happens is you just shift where the difficulty is, and now instead of knowing how to do it at a low level, it's just like, how do I do this thing in this library? How do I do this thing in this library? How do I do this thing in this library? And it's like, okay, well, if we're gonna going to have to have some type of frustration, like if the frustration is inevitable and unavoidable, we should probably pick a decently low level to go with. I don't know. That's kind of my opinion on the matter, but I don't know. It's not really about. As far as I'm concerned, it's not about making your life easier. It's more about choosing how you would like to suffer, right? So, like with debugging, right? You can either spend hours and hours debugging, or you can spend hours and hours writing unit tests. Right, but either way you're going to suffer, but you get to kind of choose how you would like to suffer. And so, for me, in terms of how I would like to suffer by writing native Win32 code and figuring that out, rather than figuring out stuff like these window wrangler libraries. That's how I like to do it. Yeah, yeah. I got the hunch that you liked debugging and whatnot. Me, I like to avoid it as much as possible, so I'm very heavy on the unit tests and, like, runtime assertions. Okay, so now over here, we can just start replacing some of this stuff, right? So we can just go, COE, and then here's our error message, and then over here, we can paste this here and say bad times number 2. And then over here, this is another bad times number 3. Then over here, this is another bad times number 4. And then over here, here's some more bad times. 5. And this is not a very efficient way to do things, right? Because, you know, this is actually, you know, we have to call the library to do this, right? So, okay, then after this, the last one we want to call is right here. So that's 5, and this is 6. Okay. So, if I don't get anything to kind of crash here, I'm going to... The next thing I'm going to do, if I can't get this to actually crash, then I'm going to assume that I'm updating the wrong rectangular region. I'm going to write some unit tests for that, and if that doesn't work, then I'm going to write like some type of shader to just test that one function call. Just test this one function call, make sure that I properly know how to update a subsection of the image, right? But one thing at a time. So we have to isolate every single possible problem one at a time and kind of hone in on the problem. We've already honed in on the problem a little bit because we already know that when we update the entire texture, the shader works properly. So we know that the shader code uses the correct math to get at the correct pixel. So that's all great. That's great. But now we got to figure out why our... Yeah, it has to be something with our texture uploading code. I just don't know exactly what the problem is yet. So we're trying to hone in on that. So let's give this a run. Okay, here's what I'm going to do. I'm going to keep on trying to get this to run. But once I get this compiling, and I've tested this out, then I'm going to be out of here. Because I just, I didn't mean to go for this long today. I just wanted to get a little bit of work done. And now here I find myself doing stuff. Yeah, so we can remove this. Okay. So, yeah, we just want to get this compiling, and then after we get it compiling, if we don't get that runtime error, then yeah, I'm going to be done for today. Like, I'm going to do my remaining... Okay, so here's the thing. So right here, this shader right here, this ready shader, is in shader slot 0. I'm thinking that instead of... Yes, it is fun to have a little thing... Yeah. Well, I do want to get to a good stopping point. I need to be at a good stopping point, right? Like, I cannot leave my code in, like, a broken, unfinished state. So the code absolutely needs to compile before I stop coding. And that's a normal rule that I always do, right? So that's a rule I always have. Because I don't think this code base would be lost if I did that. But there's definitely a lot of other projects I've worked on where I leave the code broken to where it doesn't compile. I come back to it like 3 months later and it doesn't compile, and I have absolutely no clue how to fix it. Right? It's one thing to be like, hey, I have this code and the code compiles and I have no clue what this code actually does, but at least it compiles and runs because I can now observe it and figure out how it runs, even though I have no clue what this code does. Now, if you have no clue what the code does, and you can't even compile it to observe it, you're in trouble. So, I never want to leave the code in a broken state, unless I am, like, so exhausted that I literally have to, like, pass out in the next 5 minutes. Unless it's some type of very extenuating circumstance, I do not want to leave the code broken. But anyways, I'm thinking that this shader here, which is kind of like was like a default shader, and this is in slot 0, we could make this shader a shader that gives us memory dumps, that says, here's exactly what's in this texture slot. Okay, and then you press another number, and it says, oh, here's what's in this texture slot, and it does that over and over again for you. And then the default texture slot that it'll display for you is the texture as uniform texture, so that we can visually inspect the contents of that texture. That's what I think I want to go with. That would help us diagnose if the subtexture push is working correctly. But anyways, let's go over to this shader for a second, and let's just try to iterate through the... Yeah, so we're not getting any crashes. It's not crashing. And we're printing out the selection area. So yeah, I don't know what the problem is, but I'm leaning towards... So this right here, we're calling this. We're calling this from over here right now, right? We commented out this. So my thought is that this rectangular region is wrong. That's my thought, that we wrote some tests for it, but it turns out we didn't write enough tests for it, and possibly there's like an edge case, something. So we need to write a test, and we'll write a very specific test, right? We'll write a very specific test that tests for the exact variable we're trying to set and update, and make absolutely sure that this rectangular region is correct, because I'm thinking that this rectangular region is off. And then if that's not the problem, the other problem could be that the other problem could be that these parameters are not correct, right? So oh, you know what? What we could do is we could try TexSubImage 2D, but we could give it parameters. Are you selecting a rectangle from an image or screen? Okay, good question. Is this supposed to be the rectangle that's on the CPU, or is this supposed to be the rectangle that's on the GPU? That's a good question, because I think that would make a difference. So my assumption, and my assumption could be wrong, is that this is the rectangle. Well, they have to map 1 to 1, don't they? Hold on. Yeah, so yeah, this TexSubImage thing seems kind of wrong to me. Like, because it's... Right now, we only have one rectangle that, No, I mean, yeah, but what you're saying is actually making some sense to me. Because in the WebGL version of this code, there was one extra parameter that specified an offset. And that offset was an offset into the data on the GPU. So you would take a selection rectangle for the CPU side texture, but if you wanted to know where to map it exactly, you needed to get an origin on the GPU texture as well. And there's no extra parameter for an origin on the GPU texture. So the assumption I'm making is that that this rectangle applies both to the CPU side texture and the GPU side texture. That's my assumption. So what we could do to make sure that this call is correct is we could update, instead of updating this rectangle, we could strip out this rectangle and we could use the sub-texture update to update the entire texture, right? We could just say, so right now, right here, when we push the entire texture, it works. When we partially push the texture, it fails. So what we could do is we could use the command for a partial update, but supply it a rectangle that covers the entire texture. So we could do a full update of the entire texture with the partial update command. And if that fails us, that kind of gives me more insight to say, okay, the problem is that I'm not using OpenGL correctly. But if that works, then it's probably that this pixel bounding rectangle is wrong. Probably. But then we would do one more thing where we update like 1/4 of the image, right? Or different subsections of the image, right? We hard code the rectangle update region to cover the pixel that we know we want to look at, and just mess around with that, and that could also hone us in onto what we're doing wrong as well. So that's a good idea, so I might want to make a note of that. Use partial So, that's a little thought we could do, so I just want to put that idea in there. Calling that text sub, but selecting the entire thing to be the same as using the entire image. Yes, exactly. Exactly, yes. So, you are exactly on the money. That's exactly what we'll try. Yeah, that's exactly what we're going to try. Yeah, so that's exactly what we're going to try. But we're not going to try that today. But it's a good idea for trying to figure out how to diagnose what the problem is. Well, okay, yeah. So when I'm updating the entire texture, I'm using a different command. So this command here that updates the entire texture is not using. It's not just taking the subtexture command and using a full texture size rectangle. So it actually uses a different command. So this function here, this command here, I've never used this command before in the entire code base. I've never used it before, which means that since I've never used it before, that leaves a lot of unknowns when things don't work. Because if things don't work and I've never used this command, there could be the possibility that I didn't set up the bindings correctly. There could be the possibility that I'm not using the command correctly, and there could be the possibility that the data supplied to the command is incorrect. So we got these three big possibilities. Usually I haven't found that I screw up the bindings, but if I screw up the bindings, that could lead to some serious undefined behavior and things not working correctly. There's tons of things I could be screwing up, so we have to just narrow down the possibilities of what's being screwed up. Okay, anyways, let's make absolutely sure this compiles before I get out of here, because we've got to make sure it compiles, and then, could it be something about the subtext selected not being big enough and needing a scale? Yes, so maybe, possibly, it doesn't like the idea that I'm using a 2x2 pixel area, and maybe it needs something bigger, right? Like, is that what you're saying? Like, that might be a possibility. I don't know if that is true or not, but we could try that. We could try looking that up. So first of all, looks like this is compiling. Okay, so this compiles. Let's go to our agenda for a second. I'm going to look that up after I add this to my agenda here. Subtexture push of tau memory. Okay, actually we're already on number 18 right here. It's already on the agenda. It's already what we're working on, so we don't have to edit the agenda at all. But yeah, so let's try that. So glTexSubImage 2D minimum size something or other, right? So well, let's look at common mistakes. Common mistakes are kind of helpful. So glTexSubImage 2D. So width, height, unsigned byte, pixels. creating incomplete texture. So this is not... I don't even need to read this because I know it's not an incomplete texture because we've already proven we can get information off of it. So I'm not... Yeah, and we already do this kind of stuff here. Well, actually, I want to look at TextSubImage here for a second. I don't think I have this one. Yeah, I don't know. I'll have to figure that out later. I don't know what's going on. I'll have to just figure that out later as I try to figure this out. What do we got here? Anyone? Yeah, I'm pretty much done for now. Let me close this. Yeah, I don't know what's going on. We're so close, right? Because once we get this working, then we have the ability to get keyboard input and have it registered in the shader code, right? So, and we can have, since we're using an entire texture to store different uniform values, we can start wiring up a lot of different values, right? We have, we can, I don't know. I'm tired. Let me check my push-ups. How many more push-ups do I got? I think I only have 20 more. Well, luckily for me, I only have 20 more to hit my 130 for the day. So I see that I'm starting to get to the point where I'm not doing any extra. So that tells me that I'm getting to the point where it's like hitting the number of push-ups and crunches and whatnot that I need to do every day is starting to get quite tedious. Because I'm doing push-ups, crunches, sit-ups. Like 130 means 1 push-up, 1 crunch, 1 squat, and 1 dumbbell lift. It means all of that. So, okay, yeah. So this was video 132, and yeah, I'm out of here. So I don't know when I'll be back. But you know, I'm always back on Mondays because. I'm always back on Mondays, though, right? Because Monday is coffee day, and I code for at least 16 hours on Mondays. So, last Monday was like 23 hours, I think. Because it was like 9 plus 5 hours, something like that, or somewhere around there. So, yeah, I'll be back on Monday at the very least. Also, actually, Sunday I'm going to do a quick tech demo day. Like on Sunday, it's going to be like a 1-hour tech demo day on 1 p.m. to 2 p.m. Eastern, whatever the hell time, Eastern Standard Time, EST. I think it stands for Eastern Standard Time. Yeah, but I'm tired, so I got to get out of here. I'm tired. I got to just do my push-ups, go to bed. So later. Oh, I did, yeah. Yep. So I did, I try to tell everyone. So the idea is, like, I don't have too many followers, so I can take the time to kind of, like, tell everybody. So I painstakingly messaged everyone, and then, it took a while. It seems like, what do you call it? Twitch has some guards against cutting and pasting, I think. Something like that. Not that I like so I wanted to individually let everyone know, so I individually typed out messages for every single person, because I think like after maybe the 10th message it's like it doesn't let you say the same thing again or something like that. But yeah, so as long as I don't have too many followers, you know, I need a bot. Well, maybe you can educate me on that later, how that works, how bots work. Oh, it probably detects as spam. Yeah, something like that. I mean, like, it's not like I do that every day, though, right? So it's like I'm only gonna message everyone when I actually have something new and interesting to show, and that's not very often, right? That's not like I don't have something new graphically very often to show, so it's like every like maybe month at most I have something interesting to show, so it's not like I'm spamming people. I wouldn't consider that spamming people to say, hey, I have something new to show you. I don't think that's, you know, I don't consider that spam. No one told me to F off, so I'm gonna assume I haven't spammed anyone. But anyways, okay, I'm really out of here. This has been part 64, which is 64 is not much of a sprint, so whatever I'm doing. Later.